So as we know, in last class and all, we studied what is the pressure exerted by solids. So whatever you studied till now, so pressure P is equals to what is the formula, guys? Everyone, pressure P is equals to what is the formula? Force by area, or is to called as thrust by area. Correct or not? Thrust by area. So whatever it is, everything. What is the unit of pressure? Unit of pressure is Pascal, and as we know, 1 Pascal is equals to 1 Newton per square meter. This is what we studied in the till last class. Is it yes? All of you?
Yes, sir.
Coming to here, in last class I have taught you around 10 applications of pressure in our daily life. So it will start from, like you can say, rail tracks, which are like we are keeping wider wooden and cemented or iron slippers between the rail tracks. Next one is what? Tips of a needle is made very short, and it is easier to cut the vegetables with a new knife or sharp knife other than blunt knife. Same way, our school bags are provided wider strips or small strips. Wider strips, correct or not? Wider straps to reduce the pressure on our shoulders. Same way, camels and all you can see, they're having wider foot compared to the man. That is why they can easily walk on the sand. Same way, our trucks having wider tires compared to a bicycle or a car or a bike or etc. Same way, it will take all our construction buildings and all. You can see if it is a tall buildings or normal house also, always the basement is more wider than the walls. Is it yes, guys? Yes or no? Also, we can see if you take the dams or reservoirs, whatever it is, whenever they are constructing the dams and reservoir, down the size of the reservoir will be more wider when compared to when we are rising up. Because what is the reason? That is all we'll study. So that is what basically the applications of pressure in our daily life. Now coming to here, in our today's class, we are going to start the next concept called as pressure in fluids. Now, what is this fluid? First of all, understand everybody, a fluid is a substance which can flow is called as fluid. A substance which can flow is known as fluid. Do you understand, everybody? So if you take examples of fluids are two things. So what is the examples of fluids? We know three states of matter: solid matter, liquid, and as well as gas. Now in this, tell me which will come under flow. Anyone?
Liquid and gas, sir.
Yes, all of you. So liquids. So liquids can flow easily, and as well as gases also can flow easily. That is why this together we used to call as what we used to call, all of you, we used to call as fluids. Understanding, Mama? So that is what you have to remember it. Let us call to this Divya. Arun Gailas, good morning. I call to Omar, Mr. Hari, Kaushik also. Have you all understand, everybody? So what is fluids? Fluids are the substances which can flow easily is called as fluids. So examples of fluids is liquids and gases, means that together is called as fluids. Can anybody tell me what is the best example of liquid which is known to us? Anyone, please?
Water.
Water.
Water, sir.
Very good. Gas. What is a gas which is known to us? In our surroundings, it is there. Mixture of gases. What is that? What is that, guys? What is the mixture of gases which is present in our surroundings? Yes, please.
Air, sir.
That is what I'm asking. Go with your surroundings always. So, reason behind why we used to call these two are fluids. Reason behind is, remember, solids are rigid in nature, rigid in the sense of having definite shape, but if we take liquids and gases, no particular shape they have. That is why they are called as fluids. So always they cannot, like we can say, particles are not close each other in liquids and gases. So the liquids and gases can flow easily. That is why they are together called as fluids. Understand everybody? So that is why we are going to study now properties of pressure in fluids and how it will be exerted and what is the formula to calculate the pressure exerted by a fluids. That is all we will study in our today's class. Now remember, as we studied, a solid object exert pressure due to one thing. Anybody can tell what is that? If I'll take for example myself. Now you tell me, I am exerting pressure on this ground due to one thing. What is that? Anyone hurry? Due to the force. Force means what? What force I am having? Anybody? We'll study this chapter.
Sir.
Gravity. Gravity means something. It's a gravity is multiplied with something, we'll get something. Force means. Force is a product of two things, mass into acceleration due to gravity. That force only we used to call something. Anybody? Mitakshri? Yes? Arun?
Wait.
What is it called, guys? What is it known as?
Wait, sir.
Weight means mass into acceleration due to gravity. So, every solid object, all of you please remember, every solid object exert pressure due to its what, guys? Due to their, note it down, due to their weight only. So means their weight only is their pressure. Weight only their pressure. So if you'll notice it, fluids also exert the pressure due to their weight, but you can see on the walls of the container which they are enclosed in all the directions. Suppose if I have taken, this is the container, if I will place the, suppose let me take Mr. Arun, I have kept him inside. So now this Arun is a solid or liquid or gas? Everybody? Is a
Solid, sir.
solid. So this person will exert only pressure on this surface. Everybody. So where the pressure is exerted? Pressure is exerted only on bottom surface. That is also due to its weight. Due to his weight. Understand? But in place of the same container, if I will fill with the liquid, now remember, liquid does not have any particular shape. So these liquids, remember, if I will close with the force or if I'll close with the lid, remember, now if the force is exerting like this or external force or something, then you can see, all of you, the force of this liquid is exerted on all the walls of the container. Are you understanding? In between them also it is exerting. Also it is exerting on where? Walls of the container. Even upward also it will be exerting. But we have been covered with a lid so that they cannot lift that lid, so that they cannot be come out. Even this container is very stronger so that they cannot come out. The fluid cannot come out. But in every direction, the pressure is exerted by the fluids. Have you all understanding what I am saying? Pressure P is exerted in all the directions of a fluid, all the walls of the container where we are storing the fluids. But solids will exert only on where? Solids will exert only on where? Only on the surface. Understanding? Suppose if I am standing here, my pressure is exerted only on this surface. Suppose if I am sleeping here, my pressure is exerted only on this surface. Understanding everybody? Whatever the surface is contacting to my body, that is only that place alone I will exert the pressure. Means my bottom surface alone. But if it comes to the fluids, fluids will exert pressure on where, guys? Please respond. Fluids will exert the pressure on? All of you should tell me. Pressure on walls of the containers. Walls of the containers, it will be exerting among themselves also. So each particle is exerting pressure on itself like other particles, and also they will exert pressure on walls of the container. Understand, Hari? Mitakshri?
Yes, sir.
Yes.
Everybody. So every fluid is like that only. For example, you are having LPG gas cylinder in your home. Do you all having LPG gas cylinder? Yes, please. So the cylinder will be like this. Is it as? Now,
Yes, sir.
inside, yeah, the inside the gas will be stored in this container. Now, if you notice it, this LPG cylinder, so the gas is liquefied petroleum gas. High pressure or low pressure? It is compressed gas. Is it yes or no? So highly compressed gas it is. So this gas is stored inside this one with extremely high pressure. Extremely high pressure. So that is why you can see when the gas is coming out from it, it will come very, very forcefully, because all the gas particles which are present, compressed gas particles, they always will exert pressure on these walls of the container. Every particle is exerting pressure walls on this container and trying to escape out from the container. That is what their property, because they are not rigid in nature. They don't have definite shape. So every fluid, whenever you will store inside the container, they will exert the pressure among themselves and also walls of the container. Do you understand, guys? Yes? Hari? Now, so why they are exerting pressure on walls of the container? Only one reason is they want to escape out from the container. So wherever it is possible, they always will try to search for the gap or a hole to try to escape out from the container, because they are what substances? They are called as what? Fluids.
Fluids.
So they cannot be in one place. So they want to move always from one place to another place. So that is why they are always trying to escape out from the container. That is why they will exert pressure on where? They will exert pressure on
Walls of container.
Okay, everybody, clear? Any doubt? Please respond. Is it okay, guys? Harish? Mitakshri?
Yes, sir.
Yes, sir.
Now, now observe very carefully. If this is the surface, now the liquid pressure is exerting like this. Now you tell me, is it perpendicularly or parallelly? Anyone can tell? Suppose if we'll take this is the container. At every point to tell me, the fluids are exerting pressure perpendicularly to the container or parallel to the container. I want the answer from you people. Mr. Arizeras? Yes. So now fluid is contact with the surface here. Now, is the fluid is exerting perpendicularly or parallel to the container walls, pressure? Everybody. Check it, everyone. Perpendicularly means what? This is what meaning of parallel. Perpendicularly means this is what perpendicular. Now you tell me, the walls of the container, the pressure exerted by the fluids is directed perpendicularly to the surface or parallel to the surface. I want it. Answer from you. Everybody?
Perpendicular.
Perpendicular, sir.
Perpendicular only. See here, if this is the liquid, the pressure exerted by the liquid on the walls of this one is like this. It is perpendicularly to the surface. This liquid like this. This fluid like this. This fluid like this. And this fluid like this. If it is closed container, then the upper liquid is also exerting pressure like this. So that is the first property of fluid pressure. Remember, at any point where the fluid is in contact with the surface, always the pressure exerted by the fluid is directed perpendicularly to the surface. Is it okay, guys? Yes, please. All of you understand? Next. Now, let us take one big container like a water tank or whatever it is. Now, imagine Mr. Harish is swimming at the bottommost and Mr. Kaushik is swimming at here. Mr. Harish Jairaj is swimming at here. Now, you tell me who will experience more pressure and who will experience less pressure? Anyone? So let me take this point is P1 pressure, here is P2 and here pressure is P3. Anyone can tell who will experience more pressure? I want the answer from you all. Yes,
P3.
P3, P2 or P1? All of you. Think and tell me.
P3, sir.
P3. Why P3? Mr. Kaushik, Aswin Balaji, Nimish, why it is P3? I want the answer. Gokul? Because who is deep inside? Who is deep inside?
P3, sir.
P3. Mr. That is what. So when I'm always, we have to remember from the top. Always all of you remember from the top. If the depth is increases, if depth of fluid is increases, then pressure also increases. Understand, Mitakshri? Harish Jairaj? So
Yes, sir.
P3 at P3,
Yes, sir.
pressure is more than P2 and P2 pressure is more than P1. So that is why if you want to test, if you are having a water bottle in our home, so now what you will do means a 20 rupees normal use and throw water bottle. Now you can fill this water bottle fully and if you will make a equal holes at this point P1, let me take this point and this point, you can see at which point the water will come out more larger distance. Anybody? Which point the water will come out more larger distance? Anyone?
Last one, sir.
Yes. So downmost. Understanding if I'll take this is the water bottle. Now, if I'll make the equal holes, remember here the water will be pushed into larger distance and here the water will be fall little less and here water will fall into here itself. So because here depth is greater, so the pressure exerted by fluid on the walls is greater, so that water will be pushed there. So this is what, let me take P3. Now at here, pressure is little, the height is less from the top, the depth is little less, so that here the pressure is also little less. And here the pressure is, the depth of the liquid is very less, so pressure is very small. So that is what I can say. P3 is greater than, P2 is greater than P1. Is it okay, guys? Any doubt? All of you are clear? Yes,
Yes, sir.
Google.
Yes, sir.
That is what. So whenever, that is the reason why the dam's bottom is constructed very wider. Because of what is the reason? Why the dams are constructed bottoms is very wider? Because of this reason only. Because the depth from the top of the reservoir, if you are keep on going down, so the depth of the liquid is increasing or decreasing? The depth of the liquid is increasing. So the pressure exerted by the liquid is also increases or fluid is also increases. That is why it will, to resist that high pressure, the walls of the dam or the walls of the reservoir must be constructed very wider compared to the top. Hope everybody understand. Yes, please. Everyone?
Yes.
Sir.
One. Let us take one more water bottle in our home. Now, if I have taken this water bottle and I fully filled with the water, fully filled with the water. Now, in the first attempt, observe very carefully. One property we already studied. If you are keep on going down, pressure is increases or not? If depth increases, pressure is increases or not? Yes or no?
Yes,
Yes.
Yes,
sir.
sir.
Also increases. Now, this property, everybody listen very carefully. For example, I selected at this point. This is like a three-dimensional. Imagine, guys. This is the disc-like structure. I selected three-dimensional, and Mr. Harish is kept whole at here. Mr. Kaushik is kept whole at here, and another person is kept whole at here, and another person is kept the whole at backside at the same level. Same level. Do you understand, everybody? And whole size is also same. Now you tell me, is water will come out with the same pressure or different pressure in a given depth? That is what my question. Anybody? So from the height, from the top, all the holes are in the same level. Okay. Now you tell me, in every side, the liquid exerted by here is at the same depth, or sorry, same, or it is different. I want to know, everyone. So just I'm showing for your purpose. So now tell me, at the
Same.
given height, the pressure exerted by a fluid, is it same or it is different? Yes, please.
Same, sir.
Same. Very good. How many of you say same? Is it same? Yes, Mr. Hari.
Yes, sir.
Yes, sir.
So at the
Yes.
given, all of you should remember, at the given depth, the pressure exerted by any liquid or fluid is uniformly distributed in all the directions. So that is what the one of the most important property of pressure. So all the directions undiminished. What do you mean by undiminished? Undiminished to the other parts of the fluid and to the walls of the container. So means equally distributed in all the directions. And this property of fluids only we used to call as Pascal's law. What law we used to call? Pascal's law. Are you clear, everybody? So transmitted in all the directions, undiminished to other parts of the fluid and the walls of the container. So equally distributed by its magnitude. Okay. So that is what we used to call as Pascal's law. Very, very important one. Is it okay, man?
Yes, sir.
That is what you have to remember it. So these are the properties of fluid pressure. The properties of pressure in fluids. Now, one more property which is nobody knows, but it is very very important. So let us comes to here. How many of you hear a word called as density? Can anybody tell me? Have you heard about a density? I want the formula for density. Anyone, please? Density. I want the formula.
Mass by one.
Others, mass by volume. Very good. Density of a substance will make it as a mass by volume. So remember this. This one will help us now to derive the formula for fluid pressure also. So let us take density means mass by volume. Now I will give you two fluids now. Two fluids I'm giving. So let us take water. Water density is 1 gram per cubic centimeter. And I am giving another one is air. Air density is 0.29 gram per cubic centimeter. Now you tell me who will exert more pressure, either water or air. I want, suppose I will fill two containers, one container with the water. Okay. Now another container with the air. Now you tell me which one will exert more pressure, either water or air on the walls of the container. I want the answer.
Water, sir.
Divya, Water or air? Anybody? Water.
Water, sir.
Because density of water is more, so that pressure exerted by it on the walls is also greater. Have you understand everybody? Suppose I have given water and glycerin. Now you tell me who will exert more pressure on walls of the container? Who will exert?
Glycerin, sir.
Glycerin, because the density of glycerin is more than the density of water. So that is also one of the property of fluid pressure. So fluid pressure is depends directly on the density of the fluid. Okay, if the density of the fluid is increases, then pressure increases or decreases. Everybody, yes, please. Nobody? All of you. Density. If density of the fluid, if density of the fluid is increases, then pressure exerted by the fluid is also what will happen?
Increases.
Increases.
Pressure exerted by the fluid also increases. So, for example, one real life example I'll say. So, have you all heard about mercury? Arun, Akilan, mercury. You might be heard about a mercury. Yes. Now let me take a 1 rupee balloon and I filled this balloon with the water. What I filled, guys? I filled with the water. Now, and another same balloon which will fill with the mercury. Now, I will ask someone of you to carry this both in your left hand and in your right hand. Now, if you'll start walking towards to some distance, some distance if you'll walk, after certain time, you can see the one balloon will blast automatically, but other balloon you can carry. Can you tell me what balloon will blast first? Water balloon or mercury balloon? Anyone? Let me teach. Water density is density of water is 1 gram per cubic centimeter. Density of mercury is 13.6 gram per cubic centimeter. Now you tell me which balloon will breaks first? It will blast.
Water, sir.
Water.
Water.
No.
Mercury. Mercury, sir.
Now observe very carefully. Walls of the water, if you take water in the container, so water density is less, so the pressure exerted by the water is also less. If I'll take the same mercury in the container, then the mercury density is greater, so that the pressure exerted by mercury is greater. So now you tell me, so which balloon will blast first? Mercury, Hg. Now you tell me which one will blast first?
Mercury, sir.
Mercury. Because mercury will exert greater force on walls of the container, so that a balloon walls are very, very thinner in size, so they cannot resist the pressure exerted by mercury, so it will be blasted immediately. So we cannot carry mercury balloon for a long distance, because it will exert extremely greater pressure on walls of the balloon and it will make it to blast, because the density of mercury is 13.6 times greater than the density of water. Is it true or not, everyone? Yes, all of you understand, Mr. Akhil, Aswin Balaji, Nimish, Arun Kailash? That is what. So these are the 4 properties of liquid pressure, or we can say fluid pressure, the fluid pressure exerted by the fluid. Okay, right, one by one. First point, properties of fluid pressure, or you can say properties of pressure in fluids. Properties of pressure in fluids. Divya, understand, Divya?
Yes, sir.
Yeah. Write it. First one. At any point, at any point, at any point where the fluid is in contact, where the fluid is in contact with a surface, with a surface, with a surface, comma, the pressure is directed, the pressure is directed, how guys, perpendicularly or parallelly? Anyone?
Perpendicularly, sir.
Perpendicularly to the surface. Write it. At any point where the fluid is in contact with a surface, contact with a surface, comma, the pressure is directed, the pressure is directed perpendicularly to the surface. Clear? First point, Hariseras. So, if you take any container, wherever it will come contact, it will act perpendicularly to the surface. Is it okay, guys? Nobody will answer. Yes, please.
Yes, sir.
Yes, sir.
That is what it is. Second point. Second point. At any point inside a fluid, at any point inside a fluid, the pressure is directed in all the directions. The pressure is directed. The pressure is directed in all the directions with the same magnitude. With the same magnitude. With the same magnitude. With the same magnitude. Full stop. Next, third property. The pressure at any point in a fluid, the pressure at any point in a fluid, the pressure at any point in a fluid increases with the depth or decreases with the depth, guys? Depth. If you are going deeper inside, depth is, pressure is increases or decreases?
Increases.
Increases, right. The pressure at any point in a fluid, the pressure at any point in a fluid increases with the depth. Increases with the depth. The pressure at any point in a fluid increases with the depth. Are you clear, everybody? Yes? If you want, you can draw this diagram also. Next, fourth point. If greater the density of a fluid, 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 then higher will be the pressure exerted by the fluid. Higher will be the pressure exerted by the fluid. Is it okay, guys? Pressure exerted by the fluid. Pressure exerted by the fluids. Understand? Clear, Hari? Kaushik?
Yes, sir.
Very important.
Yes, sir.
As I told you, important law. Pascal's law. Define Pascal's law. One more question. Very, very important. Pascal's law. Write it. Pascal's law. Right. The pressure applied on any part of the fluid. The pressure applied on any part of fluid, any part of the fluid enclosed in a container is equally transmitted is equally transmitted in all directions undiminished means equally undiminished to other parts of the fluid, undiminished to other parts of the fluid and the walls of the container and the walls of the container. Okay, so this law is only called as what? This is known as what we used to say, guys? Known as Pascal's law.
Pascal's law.
Ninth class you have to study. Ninth class only it will become. Again higher classes they'll say you already studied in class 9. If my words is wrong, you just check the 11th class. There they'll say as you already studied in class 9, it will say like that only. So please learn it, Pascal's law, and you finish it. Then the pressure exerted by a fluid at a given point inside the fluid, how to calculate it, what is the formula, everything we'll study now, derivation. So once it is over, please keep heading. Pressure exerted by a fluid at a point inside the fluid. That is what formula for calculating pressure. Pressure exerted. Please join back all of you so that the derivation is very easy for you to understand. By a fluid at a point inside the fluid. I will finish in 10 minutes. You can join back fast. Inside the fluid. So this is what pressure formula. Formula for liquid pressure. Liquid pressure.